All right, so today we're talking through section 9.2. This is on hyperbolas. So remember, we're talking about conic sections right now, and a hyperbola, if you think about a cone like this, a hyperbola, you're cutting a plane, you're like basically taking a slice of it. And so what it will look like when you take that slice is two parabolas basically. So it's called a hyperparabola or a hyperbola. So the first thing that we're going to talk about is the fact that this standard form, there are now two of them. One of them involves, one of them has x first, one of them has y first. The difference in a hyperbola and an ellipse in their standard forms, remember, an ellipse, the standard form looks like x squared over a squared plus y squared over b squared equals 1. So then notice this plus sign. So when you look at these two standard forms for a hyperbola, it's a minus sign. And that's the difference in these two setups. So if you see a plus sign, once it's in standard form, that 1 is on the right-hand side by itself, then it's an ellipse. If there's a minus sign between the two things, then it's a hyperbola. If x is first, like before the, in front of the minus sign, if x is first, then it opens horizontally. So like this. If y is first, it opens vertically, like this one over here. All right, notice here in my setup, we have a squared still with x and b squared still with y in both of these. Now your textbook uses a first always. Just keep that in mind that I do not. Okay, so A is still how far out you're going to count in the x direction. B is still how far out you're going to count in the y direction. So how we're going to do this is I'm going to show you what happened on this one. So this is your center. You count out 1, 2, 3, 4 in the x direction. That's A. To get to that vertice or that vertex. And count out 1, 2, 3, 4, 5, 6, 7 in the y direction. That's B equals 7 then. Notice right here, there's this box where you would typically count and then form your ellipse. Now, instead of drawing an ellipse there, I'm going to draw this box. And then through the corners of the box, we'll draw these asymptotes, the diagonals here. And then we will fit the hyperbola around that. That's basically creating our framing. So we can look at the same thing. You can find the same thing in this one over here, the one on the right here. You can see this box, right? So here's your center, and you go out 1, 2, 3, 4. So B is 4. Oh, sorry, B is just 2. That's a B is 2. The scaling here, that's 2. And then in the x direction, that's 1, 2, 3, 4. So A is 4. And you can see this box. You would, in an ellipse, you would have drawn these 4 points and then connected them with the ellipse. Now you're going to connect them with a dotted box, a dashed box, and then draw those asymptotes through the corners. So this is a vertex, this is a vertex, this is the center. Here, this is your vertex where the hyperbola actually is. Now, on this one, you can actually see the focus. These right here and here, also here and here. So the foci, if you're thinking about an ellipse, right, the foci sit just inside of the vertices. So the same thing is true with a hyperbola. It's just basically that, think about like splitting this ellipse in half and flipping those things outside. So for a hyperbola, basically you are flipping that shape, right? And here are your focus points now. They're still inside the curvature, but they're like outside of your little box. Okay, so we have talked about that stuff now. The foci here to get the, so A, let me talk through A, B, and C now. Oh, I did the same thing on this one, you guys. This is the scaling. This is 2. You see, one big thing is 2. So B is actually 3 on this one. So A is 2, B is 3. And to get the foci for a hyperbola, you do C squared is A squared plus B squared. Remember, for an ellipse, the foci, you did C squared was A squared minus B squared, or B squared minus A squared, whichever one was bigger first. Notice the minus sign in that for an ellipse, right? Standard form has a plus sign for ellipse. For the foci, you get a minus sign. The exact opposite is true for a hyperbola. In the standard form of a hyperbola, we have a minus sign. So when we're talking about the foci, it's going to be a plus sign. You can also think about that for an ellipse, right? The foci are inside, so we want C to be less than B or A, because it has to sit inside of your shape, right? For a hyperbola, here's our A or our B, right? We want the foci to be bigger than that. So we want C to be greater than A or B. And that's because we need it to sit outside, further away from center. So we want C big. So that's why we add here. Okay. So on this one, on the right-hand side, B is 2 and A is 4. And we are going to just write down the number 1 here is to give the equations of these hyperbolas. So for the one on the left-hand side, x is first because it's opening left and right or horizontally. So x squared over 2 squared minus y squared over 3 squared equals 1. And then the right-hand side, we have y squared is going to be first because this opens vertically. Y squared over b squared minus x squared over a squared, and that equals 1. Notice that it does not matter if A is bigger or B is bigger here. What matters is which one is first, which way it's opening. So if X is first, it opens horizontally, left and right. If Y is first, it opens vertically, up and down. Okay, so that's what we're going to do. We're going to go through some examples and just practice this. So we have this equation for a hyperbola, x squared over 9 minus y squared over 16 equals 1. So x is first, so it's going to open horizontally. And that's going to be important. I would write that down every time just to get into it. A is the square root of the thing under the x, so A is 3. B is 4, that's the square root of the thing under y. And then C squared is going to be A squared plus B squared. 9 and 16, which is 25, so C is 5. All right, so doing this from scratch, what we're going to do is we should talk about the center here. Just like with the ellipses, because there's nothing with x or y, the center here is 0, 0. So here's our center. A is 3, so we're going to count out 3 in the x direction. Count out 4 in the y direction, because that's what B is. And then draw a box instead of drawing your ellipse here. A dotted box, dashed box. That is, that goes through those points. Okay, and then we're going to draw the asymptotes, and they're going to be big diagonals through the whole picture. An asymptote, remember, is a thing that the graph will approach but not touch. Okay, so we have the framing done. We said that this opens horizontally, so that's where my vertices are. So I'm going to label those now. And then I can just draw my hyperbola in there. Just don't let it touch those asymptotes. And, use the framing that you drew. Okay, so we have the vertices, the asymptotes, we have the center, we need the foci. So we're going to count out 5 from center. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and those are our foci. And we have graphed our first hyperbola. Notice these directions say describe and graph. All of this is the describe part. And then this is the graph. And you need both. If you turn in something with just this graph, I will give you no points. Okay. So let's do one more before we move to ones that are not centered at the origin. So here, this one, because y is first, this will open vertically. So it'll look like this. A, B, and we need C. Remember, B is with Y for me. You can do it however you see fit. B is 4, it's the square root of the thing that's sitting there. A is 2, the square root of the thing sitting with X. Okay, C squared is going to be A squared plus B squared. So that's 4 plus 16, which is 20. So C is the square root of 20, which is equal to 4 and some. All right, our center of this thing is, because there's nothing with X, nothing with Y, the center is 0, 0. So put your center on there. Then count out 2 in the X direction, 4 in the Y direction, and instead of connecting those with an ellipse, connect them with a dashed box. Then you are going to draw your asymptotes. So draw these diagonals through the corners of your box, through the whole picture, because this is what gives you your framing. Then, as I said, this one opens vertically, so we're going to fit our hyperbola up here and down here. And then we want to put the foci on there, so 4 and some. Those are our vertices. So there is your second graphed hyperbola. All right. So you're going to try those on your own. In these ones, this one's done for you. This one, remember, you want to get a 1 on this side. So you're going to have to divide by 100 to start with. Same thing here. You want a 1 on the right-hand side. So get that 9x squared over and then divide by 144.